Welcome to Study Loop.
In this problem, on the topic of waves and sound, we're given the amplitude of a transverse wave on a string, and we're also given the ratio of the maximum particle speed to the speed of the wave. We want to calculate the wavelength of this wave. Now we know the particle of the string is moving in simple harmonic motion, and the maximum speed of the particle is given by the following equation. Vmax is equal to the amplitude of the wave A times the angular frequency omega. And we know the angular frequency is related to the frequency by omega is equal to 2 pi f. So we can write this as 2 pi times the frequency times the amplitude A, and that's the maximum speed of the particle. Now the speed of the wave on a string is related to the frequency and the wavelength by the following equation. V is equal to the frequency f times the wavelength lambda. So the ratio of the maximum particle speed to the speed of the wave is Vmax over V, which is 2 pi f times the amplitude A over the frequency f times the wavelength lambda. And we can see the frequencies cancel, so we're left with 2 pi A divided by lambda. And we can now rearrange this equation, and we can find the wavelength lambda since we have the ratio of Vmax over V. So therefore, the wavelength of this wave lambda is equal to 2 pi times the amplitude of the wave divided by the ratio of the maximum particle speed to the speed of the wave, Vmax over V. So this is 2 pi, and the amplitude we are given is 4.5 centimeters. We'll leave our units in centimeters, divided by the ratio of the particle speed to the wave speed is given to be 3.1. And so calculating, we get the wavelength of this wave, lambda, to be 9.1 centimeters.